So this is the luminol lighthouse reaction. So this works on the principle of chemiluminescence. Does anybody here know what chemiluminescence is?
Luminescence.
So chemiluminescence is basically some compounds have a tendency of converting chemical energy into light. So that is what we will be seeing over here. So first I will be adding some copper sulfate to my solution. This was copper sulfate. And then we'll be adding KCl. KCl is potassium thiocyanate. Now we will be adding the ingredient which actually gives the light, which is luminol.
Wow.
You see the color?
Yes, yes.
So now to start off the reaction, we'll be using H2O2. H2O2 is a strong oxidizing agent, that's why it starts the reaction. What is happening in this reaction is that the copper sulfate we added will react with the luminol to give the light that we see. Then this will be converted to copper plus 1, which will react with the KCl and the H2O2 we add to give back copper plus 2, which will again react with the luminol to give us. So now this is an oscillating reaction. So about every 20 seconds this will be flashing. You will see flashes of light about every 20 seconds.
Every 20 seconds.
Is it with rate of flash?
No, it could
Yes,
not
yes.
So luminol is also used in forensics. So for example, if you are at a crime scene and you want to detect blood, so they use luminol for that as well. Luminol interacts with the iron present in the blood and it lights up with the same color as you see here.
When it's oxidated or before oxidated? When it's oxidated?
So it interacts with the iron. It reacts with the iron present in blood to give.
Now you put the iron rod, then oxidation will start?
So here we are using copper.
Copper. But it was not reflected every 20 seconds what you stated. It was
Yeah.
not reflected.
Did you see?
Now it is okay.
There was a flash. Yeah, so this is what happens. So this will keep happening for about 2-3 minutes, and so luminol is also used. So it interacts with the iron and then it glows up. It emits the same light. So that's why they're able to detect blood which you cannot see which is
Normal,
even if
normal.
it's not visible when you're normalized, you will be able to detect it using this.
Forensics.
Yes.
Is it working? We made it work.
Yes.
It's working. Okay, the changes we're making all of this distilled water. We got distilled water. Oh, you guys got we're using distilled water, now it's working. The same concentration, same amount. Yeah, heat is coming into place.
So this is the same principle which is how fireflies emit light and glow sticks work. They also use a very similar concept of chemiluminescence for
I'll do the experiment first and then I'll explain later. I'm adding concentrated sulfuric acid. I'm adding approximately 50 drops of it. Now I'm adding ethanol. For this reaction, they have to form 2 different layers. So I'm doing it in a standardized process. And I'm adding it rapidly because I don't want them to mix. Ethanol. C2H3. It's an organic compound. So there are 2 different layers. It's not that noticeable, but it's there.
Two layers.
I'm adding KMNO4 pellets, potassium permanganate. Be a little.
Underwater fire. Underwater కూడా reaction. Potassium. Automatically H2 SO4.
I'll explain the reaction. H2SO4 can act as 3 things: an acid, an oxidizing agent, and a dehydrating agent. KMNO4 is an oxidizing agent. When I added the KMNO4 to the H2SO4, that is sulfuric acid, so both are oxidizing agents, no redox reaction occurs, it's just the hydrogen is shifted up. So KMNO4 gets converted into HMNO4. HMNO4 is there in a test tube, but H2SO4 is also there. It's not completely changed to another product. So remember, H2SO4 is also dehydrating agent. So 2 molecules of HMNO4 gets converted into 1 molecule of Mn2O7 plus 1 water molecule. This Mn2O7 is an oxidizing agent. It oxidizes the ethanol, which is an organic compound, to acetic acid, and produces MnO2, which is the brown color that you see. Now this reaction is exothermic in nature. It increases the temperature of the test tube to above 55 degrees Celsius. Now some amount of Mn2O7 is still in the test tube. Not all of it has converted into MnO2. So Mn2O7 is explosive at and above 55 degrees Celsius, which causes the sparks to form. Any questions? No. I mean, if you have parental supervision, I think you can, but it's concentrated sulfuric acid. Ideally, it should not.
What is the role of ethanol?